Frequency Matters, the RF and microwave update. I'm Pat Hindle, and I'm here with my co-host Gary Lerude. So in this episode, we thought we'd take a look at the July RF and microwave software and design issue.
Right.
We've been talking for many months now about the trend or shift in the industry of AESA. So there's a lot of commercial systems that are starting to look at AESA radio configurations, and of course the military has been using them for years and is even using them more and more. So our cover story is written by Darren McLaren of Keysight Technologies, and so he takes a look at phased array design for 5G, electronic warfare, and satellite applications. And he kind of looks at the trade-offs and things that you have to do in that design process. And what he does is he looks at RF and digital beamforming and how you can use a standard suite of software products across a platform to be able to design those very efficiently. So it's a very interesting article. I think it'll be very instructional for people to look at.
Yeah, definitely.
And so what else did we have for technical features?
So we have 3 other technical features, of course, part 3 in the final episode, if you will, of the Mobius metamaterial series with Ulrich Rode and AJ Padar. In this final version or final installment, they look at basically some of the trends that are occurring, some of the opportunities, some of the technical challenges still to be overcome, and then kind of a synopsis of the future. So it's, I think, a nice conclusion to the series.
Yeah, and we're still getting lots of comments online for those.
Right. And then we have an article from a joint article from MathWorks and Analog Devices about sort of a new approach to designing the highly complex radio systems, particularly in this day and age, where you take a model-based design approach using, say, MathWorks software with an existing transceiver chip like Analog Devices has, and you can really shorten the cycle time for the development. And then our third article is by Peregrine Semiconductor. As you know, the cable systems are trying to increase bandwidth. The latest standard that everybody's adopting to is DOCSIS 3.1. Of course, by going to higher bandwidth in the cable system up to 1.2 gigahertz, moving to 1.8 gigahertz, and higher complexity modulation, the key requirements that flow down to the components in the system are that they have to be much more linear. And you would typically think that it's pretty easy to do a linear switch, but that's not the case, particularly with DOCSIS 3.1. So Peregrine's article basically describes how, with the SOI process, they can reach the specifications they need to meet the overall linearity requirements and then the EVM performance of the system.
Right.
So it's pretty interesting.
Great. And so moving on to the news, there was a lot more 5G milestones that were achieved. 5G World in London was taking place, and Nokia demonstrated the first 5G network demonstrated on commercial platforms. So they took their AirScale system, used their data center platform and their cloud platform, and put together a 5G system. They were demoing it there, which is very interesting.
Yeah, it's a pretty interesting prototype.
Yeah, the AirScale uses 4.5 gigahertz operating frequency, and they used high-order MIMO antenna technology to accomplish the high throughput rates. And then, not to be outdone, Ericsson also had a very interesting demo there. They are actually doing a 5G medical use case. And they had a demo where people could actually put their hands in a haptic glove and they could remotely control a robotic finger, and then they could actually get immediate feedback as that finger touched the skin. So you're now seeing the low latency come into fact that you can get an immediate response doing remote surgery and other things that are going to take those low latency systems.
That's pretty impressive.
So
it's hard to imagine that.
Amazing stuff. I just feel the 5G, it's just, it's happening so much faster than we think. And I think that's really going to take a lot on the test and measurement simulation end and device end to get this done really quickly. We're seeing demos this year, and next year we'll be rolling out left and right.
Yeah. Well, a couple things from the semiconductor front that I saw that I thought were interesting. One, at the mobile phone level, Skyworks announced that they had a very significant design win in the Huawei P9 and P9 Plus smartphone. Looking at it, they virtually captured, I think, almost every RF socket in the phone with
that was amazing.
10 devices. Their Sky1 integrated front-end module, they basically have both the or all of the bands, so the low, mid, and high band, and then a lot of peripheral circuits that go around with it. So Huawei is the #1 smartphone manufacturer and the first Chinese manufacturer to deliver over 100 million cell phones. So I think that's a nice win for Skyworks. Then at the other end of the spectrum, we heard from Infineon that they have, by the end of this year, they're projecting about 50% market share for the ICs in automotive radar at 77 gigahertz. And that means that 1 in every 15 cars that's shipped is going to have their chipset in it. And it's quite interesting. I can remember a number of years ago, you probably do as well, when MACOM did one of the first automotive radars at 77 gigahertz. And then I know TriQuint had a version, a chipset in gallium arsenide. Now it's all gone to silicon germanium, and it's really starting to take hold that due to the safety benefits of the radar system, there's mass adoption that we're going to see in the next few years. And in fact, Infineon has delivered about 20 million chips to date. They think next year they'll do 30 million.
Wow. Yeah, I remember, and they were very costly back then, very complicated, and now they're very low cost. So you see them rolling out on almost all styles and models of cars.
Right. So what else is going on?
So we're very fortunate in that some visitors from National Instruments are here at Frequency Matters today.
Yes.
So they have a big announcement. They're going to talk about some industry trends, and they have a big unveiling of a new product that they're going to be introducing to the market. So let's take a look at that introduction.
So if you imagine what it would take today to test a gigahertz of bandwidth, an analyzer and a generator, to keep up with the latest serial standards, the latest parallel standards, while keeping costs down, you imagine what a solution from a test and measurement vendor would be like. You'd probably imagine it to be a large stack of equipment at a pretty high price. I bet you would never expect it to fit in the palm of your hand.
Let's see it. It's coming.
But we're happy to announce the second generation vector signal transceiver from National Instruments. It offers 5 instruments in a small package, an RF analyzer, an RF generator, a powerful FPGA coprocessor, the ability to control the digital pins of your device, and now a 5th instrument, 12.5 gigabit per second serial interface. It offers both a gigahertz of bandwidth on the generator and the analyzer. That's 5 times the bandwidth of our previous solution. It offers 5 times the amount of signal processing horsepower in the device that you can program with LabVIEW. Offers twice the measurement accuracy, extended frequency range, but preserves the same software environment that's been so popular with the first generation vector signal transceiver.
Yeah, and that's really critical about a device like this is it's programmable with LabVIEW. It's completely open and customizable in a way that allows the customer to take that domain knowledge, the intelligence they have about their markets, the devices that they have that they need to test, and apply that knowledge to customize this set of 5 instruments in a way that allows them to meet the business and technical requirements of their job. It's truly a revolutionary approach to this space, but frankly, that's where we're at. That's what's needed, given the pace of change and all the requirements of these connected devices. This is the type of instrument that sets you up for the next 5 years of all that wireless change that's both happening now and going to happen in the future. And it's really the epitome of the customer knows best approach that we started talking about here. So we're really excited to be able to roll it out for the audience here today.
Wow, that was extremely interesting. The new VST, the second generation, I think is going to be a huge impact on the market.
Yeah, it's hard to imagine how disruptive it is. I think it's quite impressive.
I don't know how they get all that technology into a 2-slot PXI module. That's incredible.
Exactly. Well, it'll be good to see how the market responds.
It will be. So for events, we have some exciting news with ED Icon USA. We released the 4 short courses that'll be taught at that event. They're very interesting topics taught by very good experts in the RF and signal integrity market. We have microwave filter design with EM simulation by Dan Swanson, very well-known filter guru, has written a couple books, and he's an IEEE fellow. We also have one on the fundamentals of power integrity, and it's taught by Heidi Barnes of Keysight Technologies and also Steve Sandler from Picotest. And they're both experts in both signal integrity and power integrity. And we have one on radiated emissions and using that for evaluation and pre-compliance testing. So Ken Wyant, he's a very well-known EMC consultant and also editor of the Interference Technology magazine, so very well-known in that market. And then finally, our ED Icon USA honorary chair, Dr. Eli Bruckner.
Oh, yeah.
Over 50 years at Raytheon. He's a guru in the radar market, and he'll be talking about the fundamentals and also new advances in phased array, MIMO radar, and radar techniques.
Well, you and Janine have been working really hard to get the conference put together. I hope you have some time this summer to take a vacation.
I don't know, we have to get ready for September, but
that's true.
Janine's doing a great job, so that helps.
Well, I think that's a wrap, isn't it?
I think it is.
Well, we want to thank you for watching, and in particular, we want to thank our sponsor, Mini Circuits, for making this program possible. You can find out all about their products at their website, minicircuits.com. Thanks for watching, and we look forward to having you join us on the next episode.